Okay. Okay. Hi, my name is Marcel Crescenzo, and unfortunately I can't join the meeting, but my collaborators will attend, in particular Vittorio Braga, who wrote with me, and Silvio Reccia, the math metric that we discuss. Okay. Well, to be short, our aim is to understand how it is possible to generalize in a more complex software the metric we wrote during the process of optimization of service strategy. Pulsating, where is the cursor? Pulsating star recovery.py, this is the name of the metric, was designed to be a math metric that quantifies the recovery of the period and the shape of light curve of a given pulsating star, given the service strategy and a template of the pulsating star. Actually, the metric builds and analyzes the time series when the template is put in a given position in 3D sky, computes the periods with Gatsby, this means using a multi-filter approach, derive the best fitting curve, and at the end computes and put all this information in a complex dictionary, compute the difference between the magnitude, mean magnitude obtained in this way, and those derived from the template. Do the same for the amplitudes, and this is because we think that these are very useful quantities in order to judge our recovery and also to judge the selected service strategy regarding the chosen scientific case, obviously. Now our metric works on Data Lab within the Ruby math environment, and everything is described on our GitHub, where you can also download the metric and the related notebooks, and here the path. Actually, we are also concluding the paper that describes this metric, and we are confident that it will appear very soon on the APJ focal issue on the Ruby service strategy. Okay, what next? We want to translate this means convert and modify this metric in a tool, so in a real software running on the science platform, and giving us the opportunity to perform a similar analysis on temporal series extracted directly from the data. This will give us the opportunity to focus on some selected scientific cases, such as, for example, the pulsating stars in massive stellar systems, such as dwarf spheroidal, or in a crowded environments, for example, the galactic plane or the central part of the global clusters and so on. The output of this software will be certainly the periods and all the parameters that of the fitting light curve, some of which, for example, are useful for deriving metallicities. But we would also like to provide a whole series of quantities that help to understand how good the recovery was. This will be crucial during the survey itself, but mainly in the preparatory phase, in order to focus on most important scientific cases involving pulsating stars. So this is, in our opinion, this is a way to enable early science with the very first releases. And this is why I think that the whole pulsating star community will be interested in this type of software. That's all. I apologize. Yes, I apologize. I exceeded 2 minutes. Thank you for this opportunity and have a good workshop.